Okay, so what we're going to look at now is this idea of the what's known. So if we've something like this, so it's an irregular shape, how do we go about measuring the area of it? And what we can do is we can use this what's known as the trapezoidal rule. Okay, so I'll just put this up here. Trapezoidal rule. So just the rule, I'll put this down here just, and then I'll explain all the parts of it. So the area, so if we want to get the area of a shape like this, so the area is going to be equal to, and it's not actually equal, it's approximately equal to, so it's this kind of squiggly equal sign, so that it's not exactly equal to. So the height over 2, and then it's you multiply that by the first, so it's the first plus the last, and plus twice the rest. So it's the first plus the last plus twice the rest. Okay, so if we have a shape like this, so imagine we have this irregular shape. So this could be, for example, the boundary of a lake, for example, and you want to try and find out what area that lake covers. So it's not a regular shape. So what you can do is you can draw a line along the bottom, and you can start to split it up into these divisions. Now, and the divisions, okay, whatever size the division is, you have to stick with that. Okay, so it has to be the same. So if it's 18 here, it's going to be 18 here, 18 here, 18 here, 18 here, and 18 here. And this is what's known as H. Okay, so these divisions in here are going to be what's known as this value, or this value for H. Okay, so that's H. So if you like from here to here, these divisions, whatever that length is, this is your H value. So the more, if you were to look at this, if you were to divide, if the smaller you make H and the more of these divisions that you make up, the more accurate, let's say, your area estimation is. So remember, it's an estimation of the area. So the wider these H values are, the less accurate the area that you calculate is going to be. The smaller you make these divisions, the more accurate it's going to be, your measurement. So then what we have then is we have these, so if you see, we have these like other values here. So you have the horizontal line along the bottom, and that's broken up into divisions, and each division is what's known as the H value. Then you have these perpendicular lines coming out of this bottom value. So in this case, this first one is 10, this next one is 25, 30, 38, 36, 22. So these values here are what's known as sometimes they're called the Y values. But these are, when we talk about like the first and the last and then twice the rest, what we're talking about are these values here. So it's the distance from the horizontal line at the bottom right up to the point up here, let's say on the top here. So how then, if we were to look at this, so this first measurement here, and this height is going to be from here to here. So this is your first. So this is the first. And then if you were to go to the very end here, so this last point, so this point here, so this is your last. Now notice in this case, there's the last value, it's 0. There's no height there. Okay, so this will be your second last, but this is the last and then this is the first. So what you could say then, looking at this, so your height h is equal to 18 meters. The first is equal to 10 meters. The last is equal to 0 meters. So it's pretty straightforward, okay? So you just have the value along the bottom and then the vertical values then, and we have a number of them. And then you just have to focus on the first one, which in this case is 10, and the last one, which in this case is 0. So it's going to be, if we were to write out our formula then, so it's going to be, let's just do it in a different color. So it'd be something like this. So area is going to be equal to the height, which is 18, over 2 times the first, which in this case is this value here. So the first is 10, plus the last, which is this value here, 0, plus, and then it's going to be 2 times, so plus twice the rest. So it's going to be 2 times, for example, so these are going to be the rest here. So you have your 25, your 30, your 38, your 36, and your 22. So you would add these up. So let's just do that. Make a little bit of space. So it's going to be 2 times, so 25 plus 30 plus 38. And let's just let me just move this in. Plus 38 plus 36 plus 36 plus 22. Okay, so that's how, so if you're to take this formula and take the values I have here and put them into the formula, it would look something like this. So then what we do is we just add these up, so add it up and then multiply it. So the first thing you do is just add all of these up here within the bracket. So let's just do that. Okay, so you're going to have 25 plus 30 plus 38 plus 36 plus 22. So that's equal to 155. So we'll say, let's say it'd be 155 multiplied by 2 plus 0 plus 10, and then all of this by 18 over 2. So then 2 times, so let's just work this out then. So 2 times 155, so multiply this by 2, that gives us, so that gives us 302 plus 0 plus 10. Okay, so that's 312. So 312, and then 18 over 2. So then we would divide this by, so you can do it either way. You can turn this into a decimal by dividing the bottom into the top. So you could say, so 18 divided by 2, 18 divided by 2 is equal to 9. So that's going to be 9 times 312, and that's going to be equal to 9 multiplied by 312. So it's going to be equal to 2808. So 2808. And remember, this is area, so you're dealing with 2 dimensions, so it's going to be meters squared. So that's generally like how you would use, that's how you use this rule here. And it's just important that you know the different parts. So use the trapezoidal rule to estimate the area of the lake. So this here is roughly an estimate, so it's an estimate of the lake. So area, and you use these kind of squiggly equal signs. It's not exactly equal, it's a rough estimate. It has an area of 2808 meters squared. So that's how, so just very briefly, so you have this h value in your formula. The h value is for example the distance between each of these points, and it's going to be the same. So in this case it's 18 meters. The first is this first length here, this first, like, so let's say the height from the bottom to the top here, that's the first, so the value in this case is 10, and then the last is this here. Okay, so there's no height in that, so the value is 0. So, and then the rest are, like, you're dealing with the distance from here to here. Okay, so they're all slightly different, you can see. So that's what we mean by, you know, the first and the last and the rest. And then you just put the information into the formula and you work out what your approximate area is. Okay, so that's that first one. So let's move on down then to the next type of question that you could be asked. So if we look at this one here. So again, we have our regular shape, but what you might notice with this one is that we have 2 values. We have 2, let's say, lengths. So again, if we just remember our formula, we'll just write it in. So area is going to be equal to, it's going to be approximately equal to height over 2 times first plus last plus twice the rest, plus 2 times the rest. Okay, so the first thing we want to do is we want to identify the height. So if we have a look here, so we're looking at the height is going to be from here to here. So this value h is going to be the same the whole way across. It's going to be exactly the same. So we see here it tells us that the height is 12 meters. So h is equal to 12 meters. So you can see that it states it here. The next thing then, you want to look for the first. So the first is going to be this point here, and it's going to be whatever the height is, whatever the vertical height is in relation to the horizontal line. So we can see that there's no height here for the first, so the first is actually 0. So the first is equal to 0. Now if we have a look at the last, okay, so this is the last point. Now you can see here, so we have a height from here to here, and then we have a height down the bottom from that point down to here. Now just to go back to this as well, so if we think about this coordinate here, the first, okay, so it has 0 height, let's say, going up, and it has 0 height going down. So the first is going to be equal to 0 plus 0, which is equal to 0. Okay, so you add the height going up and the height going down. When you have this type of shape where you have, let's say, you have an up value and then you have a down value in relation to the height, so you just add them together. So then if we think of the last then, is going to be equal to, so we're going to add this and we're going to add this. So you're going to add, so these are the last. So this value and this value. So you're going to add them together and that'll give you the value for the last. So it's going to be 23.4 plus 12.1. And that's equal to, if we were to add those up, it would be so if we were to add these, it's going to be 35.5. Okay, so that's the value for the last. So then what you have to do then is you have to go and you have to add up all of these other values. So it's going to be then 2 times the rest. Okay, so it's going to be 2, so you're going to add up this value and this value, then you're going to add up this value and this value, then you're going to add up this value and this value, and then this one and this one, and then this one and this one. Okay, so we can take our formula then and we can put in what we have. So the area then is going to be equal to, so the area, I'll just do it down here. So area is going to be equal to height, which is 12, over 2, times the first, which is 0, plus the last, which is 35.5, plus 2 times the rest. Okay, so we have to add all of these up. So let's do that now. So it's going to be 11.4 and 10.6. 11.4 plus 10.6 equal to 22. So it's okay, so it's this and this, so that's equal to 22 plus, so 8.5 and 7. So 8.5 and 7 is going to be 15.5 plus, let's just move this across so a little bit, give ourselves some more room. Okay, so okay, so that's those two, so 22 and then fit, so 8.5 and 7.5 is 15.5. Then if we take 15.5 and 15.5 and 15.5, that's going to be 31, plus, so then 16 and 9.5 would be 25.9, plus 9.2 and 13.4 would be 22.6. 22.6. Okay, and then that's that. And then we can just close this up. So then what we have to do is we multiply this out. So let's see. So you can add up everything inside here. So add up everything inside the bracket. So that's going to be equal to, so it's going to be 22 plus 15.5 plus 31 plus 25.9 plus 22.6. That's 117. So it's equal to 117 multiplied by 2 plus So 0, so that's 35.5, and then all of that is going to be multiplied by 12 divided by 2, which is 6. So we can multiply this out. So 2 by 117, 2 multiplied by 117 is equal to 234, then plus this 35.5 plus 35.5 is equal to that, and then multiply that by 6. 6 is equal to, so it's equal to 1617. So your approximate area, so 1617. So your area is approximately 1617 meters squared. So if we were to take this then, so at equal intervals of 12 meters along, so from here to here, perpendicular measurements are made. So these are your perpendicular measurements to the boundaries as shown on the sketch. So your boundaries, these are your boundaries here. Use the trapezoidal rule to estimate the area of the piece of land. So this is the area, the estimate for the area of your piece of land. And we've just used this trapezoidal rule, which is this one here. The land is valued at 280,000 euro per hectare. So find the value of the price of land. So note 1 hectare is equal to 10,000 meters squared, and we have, so it's okay, so this is what it's worth per hectare. So what we have to do is we have to find out how many hectares have we got, let's say, within this value. So what we do then with this one is we take, so it's going to be the, so what we have, so we have 1617, that's we have 1617 meters squared. So we want to find out how many hectares have we got. So 1 hectare is 10,000 meters squared. So how many 10,000 meters squared are inside this? So we divide this like that. So you divide, so this will tell you how many hectares we have. So if we work that out, so 1617 divided by 10. Okay, so that's how many, so we've roughly 0.1617 of a hectare. And then each hectare costs 280,000. So then what we can do is we can take this and multiply it by this value. So you could write it like this. We go back and do it on the calculator. So it's that divided by that multiplied by 28,000. 280,000 should I say. So 280,000. So what's that equal to? So that's that divided by that. So now we can multiply this out, multiplied by 280,000. So it's roughly 45,276 euro. So this is going to be equal to 45267. 45267 euro. So this is the value, let's say, based on the area that we've calculated, this is the value of this piece of land. So it's worth 45,267 euro. So again, that's just an introduction to this idea of what's known as the trapezoidal rule, and you generally will use it to measure the area where you have boundaries, for example, like lakes and land and things like that, that is irregular, and you'd use this rule as well. Okay, so hopefully that makes sense, and thank you for listening.